And we live. Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome, welcome, welcome to your favorite math show on the planet, the K-Way Qurtuba online math show here on Hilaal TV. Now, we apologize for last week, with all the international politics that are going on around, and we had the pledge line going on. It took precedence over the math show, and obviously today we are back live in studio here in Ravonia in Johannesburg, South Africa. Remember, guys, for the show that we missed out last week, we're going to do a double bumper edition show next week, Thursday, the day before you write Math Paper 1, Grade 12s. Remember, this is countdown. Next week, Friday, you meet your Moses, right? So the night before, on that Thursday night, we're going to come to you live again for 2 hours. We're going to do a bumper episode from 9 o'clock at night to 11 o'clock at night here on Hilaal TV. So, good to have you all back onto the show. I left you in our last program where we ended off, which was last week, Tuesday's live program, by the way. I left you with this program. Cos 6a plus cos 2a is equal to 2 cos 2a cos 4a. So for those of you who just joined the show, I just want to say welcome, welcome, welcome. And a big shout out to this parent. I don't know who you are. I hope you send your name. I'd just like to say this or repeat this message that came through. Good day, Mr. K. I'm a parent. I'm so sorry we only got to know about the program only now. I got hooked and enjoying the show. And you know what? Even I can understand and follow what is going on. Keep being the difference. Thank you so much for that comment from the parent to send your name in so we can give you a nice, good shout out here, a loud shout out here on the show, live here from the K-Way Math Show. It's comments like this that keep us motivated, that keep us driven in order to make sure that you, the parent, the learner, the teacher, are prepared, you're enjoying the show, you're getting a new culture, a new vibe for mathematics, and you're seeing mathematics in a different light. Okay, but for now, this is for grade 12s. Remember, we're doing paper 2 today, so I'm going to ignore the paper 1 questions that came through. I'm going to focus on paper 2 higher order. We've got a bumper lineup of questions for you. So stay tuned, take out your scientific calculators, be hydrated, take out your writing instruments, scientific calculators, and let's get cracking. In fact, before we get started, I came across some Japanese techniques. Now, remember, mathematics is also, you got to have a good mindset. And these are life techniques. So I'm going to just go to you. I've written it here on the board, right? And this is for you, the viewer, as well. These are Japanese techniques, but the roots are also deep into Islam, right? So if you take the first one called Ikigai, which means discover your purpose. So these are Japanese techniques to overcome laziness, to stay motivated. So it's not only for you, the learner, but for the parent, teacher. You know, sometimes you wake up in the morning, you just cannot get through the day. Here's some of the techniques which I also employ in my personal life in order to keep me so driven. Number 1, Ikigai, to discover your purpose. Number 2, Kaizen, to focus on small improvements daily. Right? Don't worry about the big picture. Little by little, I promise you, you're going to achieve big results. Even Nabi Sallallahu Alaihi Wasallam, our Prophet Muhammad, peace be upon him, said, you know what? What is most beloved by Allah is those actions which are done small but consistent. Don't worry about the big things. The big things will take care of themselves. But focus on small improvements daily. I promise you, you will see the results. Right? It's like going to gym. Right? You can't go in there and start going to lift 100 kilos on the bar from day one. You start off with 5 kilos, 6 kilos, 7 kilos, and it's going to take you a little bit of time. And the more you put in, the more you gym. This is mind gym, by the way. Mathematics is mind gym. The Pomodoro technique. Work for 25 minutes and take a 5-minute break. Focus, concentrate, put your phone aside. Focus 100% for 25 minutes flat. Give it your full attention, like what you're going to be doing on today's show. You're going to be focusing for 25 minutes. We're going to take a 5-minute break. We'll get back. We'll focus for another 25 minutes. So we're going to be applying the Pomodoro effect. Hara Hachibo. Right, don't worry, we're not eating sushi here. Right, this is not a samurai course. But Hara Hachibo, you eat only until you are 60% full. Our Prophet, beloved Prophet, peace be upon him, also said, your tummy is broken up into 3 parts. Fill the 1/3 with water, 1/3 with food, and 1/3 leave empty. And that will give you increased energy. So If you employ this technique, you know, those of you who ate pup and fleece tonight and you lekker full, you're watching me now and your faces, maybe my face is becoming bigger and smaller on the TV because you're starting to spin because you're sitting with a full tummy, right? Leave a third empty so that you can concentrate, gives you increased energy. So eat only until you are 60% full. Don't eat with till you have a full belly. Soshin, approach each task like it's the first time that you are doing it. Okay? Where do I get it? I've been doing mathematics for 20 years, but every time I do a problem, guys, every time, and hopefully you can apply this in your exam, approach it with the same enthusiasm as if you did it for the first time. Same thing with you, getting up in the morning, going to work. Oh, my word, I'm going to be doing the same dreary thing every single day. No, come on. Wake up in the morning, wake up with that increased vigor. Tell yourself, convince yourself, this is my first day at the job, and what will I do in order to be an asset to the company that I'm working for or to my employer so that at the end of the day, I don't become a liability. Right, so Soshin, approach each problem, even in mathematics, like it's your first. The last one, what we call wabi-sabi, right? And that is the wabi-sabi effect means you embrace imperfection, okay? Nothing is perfect in life. You will make certain mistakes. Even when you're looking for a partner or relationship, nobody is perfect. Embrace the imperfection and you'll see how fulfilled your life will be. So these are just the 6 Japanese techniques. You can take them down, watch the show, employ them in your personal life, and I promise you, you will see a difference. Ikigai, Kaizen, Pomodoro technique, Hara Hachibo, Soshin, and Wasabi. Right, we are doing Hattori Hanzo, the Japanese sword. Let's go. Let's get back to math. Okay, so enough of some personal motivation there, just to get the show going. I left you with this problem, guys. Cos 6a, prove that cos 6a plus cos 2a. Now, this is a problem that beats many people. It came through us on our WhatsApp, and we're going to be cracking it now. So let's see. The first thing you're going to identify, let's get a different color pen here. The first thing we're going to identify, we're going to look at the 6a and the 2a, and we're going to look at the right-hand side, and we're going to see 2a and 4a. Now, what is the relationship between 6a and 2a and 4a? Okay, so here goes. We're going to start on the left-hand side. So left-hand side, right-hand side. That is your equal to sign. Left-hand, right-hand side. So in your answer, let's start on the left-hand side. And we're going to start off with cos 6a plus cos 2a. This is not cos squared a, it's cos 2a. So cos 6a, this will be broken up into cos 6a in terms of 2 and 4 would be 2a plus 4a, or 4a plus 2a. Let's write it as 4a plus 2a. 4a plus 2a plus cos 2a. If I break it up into a 4 and a 2, right, this is going to be cos 2a is going to be cos 4a minus 2a. Right, so 4a plus 2a will give me 6a. 4a minus 2a will give me 2a. Right, how did I get this? How did I know? Now you might be asking yourself, but sir, Mr. K, how did you know that you had to break this up? Obviously, look at your right-hand side. I'm going to say it again. 2a and 4a, there's a relationship. 2 plus 4 will give me 6. Or 4 plus 2 will give me 6, and 4 minus 2 will give me 2a again. Now we break this out. This is our compound angle. So let's break it up. I'm going to move a little bit to the side because of space. Cos of my compound angle is cos, sine, sine. Remember, cos of a compound angle, cos, sine, sine. So we're going to say 4a, 2a, 4a, 2a. And because it's cos, C for change. The sign changes. That breaks it up into this. Plus, now if this was a negative sign, you have to use brackets. But it's positive, so I can just say plus. And now cos 4a minus 2a will become again cos, sine, sine. We're going to get 4a, 2a, 4a, 2a. And because it's minus, we're going to put a plus because cos changes the sign. So we're almost there. Let's look at what we have. We got minus sine 4a, sine 2a. and we got plus sine 4a, sine 2a. So negative of a one term, positive of the same term cancels out. Now what do I have? Cos 4a 2a plus another cos 4a 2a will give me 2 cos 4a cos 2a, which is the same as saying 2 cos 2a cos 4a, and therefore our left-hand side is equal to, therefore we can say left-hand side is equal to right-hand side. And there we go, guys. You will get 4 marks for that. I hope you guys enjoyed this. Right? You had a whole week. Grade 12s, you had a whole week from last week Tuesday's show till today's show. Remember, today is another live show. So keep your comments coming. Keep your questions. If it's for paper 2, send it through 065-863-1440. That's the number to WhatsApp. I'll pick it up here on my phone as we are here in studio. Okay, so guys, take this down. Learn this one. Practice on it. Like I promised you, today is a cracker show. I've got one problem or one challenge that's going to take us the better part of the entire next half or next segment after the break. So that's the question that I have there. Let's look at another question that came through. Let's look at another question that came through. And this one is going to also, it probably might hit you for a 6, but let's do it. Hope you guys are enjoying the show. Prove that cos 4a, we're now going to do, prove that cos 4a is equal to 8 cos squared a. Let me just check. No, 8 cos to the power 4a. Let's see what it says. Minus 8 cos squared a plus 1, am I right? Plus 1. There we go. We got to prove this for 5 marks. Take this one down. Take this one down, right? Let's see. Those of you who have started, you can already start working out this problem. Like I said, we've got another cracker problem that's coming up. So please stay tuned to tonight's show. Stay tuned. Okay, let's see. What are we going to do here? Whew, let's go. That's your question. And this is your answer, guys. Cos 4a. Now we need to break this up into that. So let's start on our left-hand side. Cos 4a. Now, cos 4a, if I break it up, remember, I need to break it up into the cos double angle. So this is going to be cos 4a will be 2 times 2a. Agreed? I'm going to put a tick here. I'm going to put a tick here. It means that you understand. This is your double angle for cos. That's your rule. Cos 4a is cos 2 times 2a. Now, cos of your double angle in terms of cos. Remember, you got 3 rules. Cos 2a or cos 2x, 2 times x, right? 2 times x is broken up into, here are your rules on the side. It's either broken up into cos squared x minus sine squared x, or if you want it only in terms of cos 2 cos squared x minus 1, or if you want it in terms of sine, 1 minus 2 sine squared x. So these are the 3 rules that we can use. Which of these 3 are we going to use? We can either use rule number 1, rule number 2, or rule number 3. Which one are we going to use? Let's look at our right-hand side. Our right-hand side is only in terms of cos. So which of these 3 here, which of these 3 from our set of rules only has a cos? I cannot use the first one because it's got cos and sine. I can't use the third one because it's only got sine. The only one I can use is 2 cos squared x minus 1. So let's go. Let's go. So this is going to be cos 2a is 2 cos squared 2a minus 1. Remember, this here we can call x. So cos 2x is 2 cos squared x minus 1. So it's 2 cos 2a minus 1. Okay, so don't make a mistake with this. Please, in your exams, you can answer this exactly the way I do it. This is a template. It's a copy and paste template that you can use in your exam. So there we go. I'm going to put a tick. You understand that? Okay, so now let's see. We need to get this to look like that. What are we going to do? What are we going to do? I know some of you are working on this already. What do we do with that squared? Just going to have a sip of water and then we carry on. Let's go. Let's go, let's go, let's go, let's go. So now, many of you don't know what to do here. So you're going to say 2. Now, cos 2a squared. You're going to break it up into your brackets like this. Cos 2a squared minus 1. That's what we're going to do. Okay. Now, we're going to break the cos 2a in terms of cos. So this is 2 into cos 2a in terms of cos is 2 cos squared a minus 1. We break that up into that, minus 1. Right, it's getting hot in here. It's getting hot. It's getting hot. So we break up the cos 2a into that. Right, let's break this up. Let's multiply this. Let's distribute. So 2 times 2 is 4 cos squared a. Please, Lord, let this thing work out. Right, is 4 cos squared a minus 2. 2 times minus 1 minus 2 minus 1. Whoa. We forgot the squared. We forgot the square. We forgot the square. We forgot the square. Okay. I hear you. I hear you. I hear you. So let's go back. So that's 2. Cos 2a is 2 cos squared a minus 1. We forgot the square. Minus 1. Let's go again. Let's go again. That's 2 into. We're squaring a binomial. We are squaring a binomial. So we square the first term. 2 squared is 4. Cos squared. 2 times 2 is 4a. So we squared the first term. We multiply the 2 terms and times it by 2. So that's minus 2 times 2 is minus 4 cos squared a. So I multiplied the 2. That gave me minus 2 cos squared a. And then we doubled it. So we multiplied and times it by 2 to get our middle term. Plus 1. Minus 1. Right. So we remove the brackets. Now we distribute, guys. Now we distribute. So let's see, what do we have? 2 times 4 is 8 cos 4a minus 2 times 4 is 8 cos squared a. 2 times 1 is 2, right? So we've multiplied the 2 inside, minus 1. And here we go. There's our final answer coming up, guys. 8 cos 4a minus 8 cos squared a plus 2 minus 1 plus 1. That is equal to your right-hand side. Therefore, left-hand side is equal to your right-hand side. And there we go, guys. 5 to 6 marks on this question. Take this one down, guys. Take this one down. You can answer it in your exams exactly the way we've done it. So cos 4a is 2 times 2a. 2 cos squared 2a minus 1. The 2a is here. You bring the square to the top. Break this up into its rule. 2 cos squared a. Don't forget the square sign. There's a square. That square is that square there. Minus 1. Now we remove the brackets. Square the first term. Multiply the 2 and times it by 2. Square the second term. Minus 1. Right. Now we distribute. 2 times 4 is 8. 2 times 4 is 8. 2 times 1 is 2. Minus 1. 2 minus 1 is 1. And there we go. Left-hand side is equal to your right-hand side. Hope you guys enjoyed this segment. Hope you guys enjoyed this problem. Are you guys ready for the killer? Are you guys ready for the killer? Let's see how much time we got left. Oh, we've got some time left, guys. So I'm going to put this one on the board. This is going to go through our break and even after the break. So I hope you guys are watching and paying attention. Thank you all for all your questions that are coming in from across the country. Okay, so I'm going to put it down. I'm going to put it down. And let's see, we've got 5 minutes left before we're going to go for break, right? And then you're going to continue with it. So now they tell us if, this is one of the questions, if P equals cos alpha plus sine alpha and Q equals cos alpha minus sine alpha. This question came from Leroy. Right. Find, let's see the three questions. Question number 1, cos 2 alpha. Question number 2, tan alpha. And question number 3, let's see what question number 3, what was it there? And then simplify. So this here is in terms of P and Q. So this is in terms of P and Q. And then the next question that they're going to put there, simplify. It's all to do with this question. P over 2Q minus Q over 2P to a single trig ratio of alpha. To a single trig ratio of alpha. Right, let's see your mark allocations, because obviously the mark allocations are going to tell you the level of difficulty of these questions. So the first question is worth 3 marks. The next question is worth 5 marks. The last question is worth 6 marks. Now, obviously, if you get the first one right, you haven't yet passed the question. So you got 3 plus 5 is 8. 8 plus 6, you got 14 marks in your final exam. This was a final exam question that came out from one of the past papers. I saw Leroy sent it to me here on the phone. I took it down, and we are now going to crack it. So here we go. That's the question. Take it down. Take it down, and let's see whether you can get started with this. All right, I think we've got a couple of minutes left. I think we've got about 2 or 3 minutes left. 2 minutes left. Let's do the first one. Let's do the first one before break. We're going to take about a 5-minute break, and let's see within 5 minutes if you can do number 2 and number 3 with regard to this question. I hope you guys are enjoying the show. Okay, like I promised you, bumper show for today. Let's go. So we need cos 2 alpha. What is the relationship? So I'm answering question number 1. Cos 2 alpha. And what is cos 2 alpha in terms of cos and sine, cos and sine? So cos 2 alpha is equal to cos squared alpha minus sine squared alpha. That is your rule. Now, this is the difference of 2 squares. So this is going to be cos alpha minus sine alpha. Difference of 2 squares into cos alpha plus sine alpha. We're going to put the final answer and go for break. Cos alpha minus sine alpha is P. They want your answer in terms of P and Q. So this is P. And cos alpha plus sine alpha, cos alpha minus sine alpha was Q. And then cos alpha plus sine alpha was P. So obviously your answer is QP or PQ. PQ or QP. It's the same thing. You'll get your first 3 marks for that. So that was quite a simple one. It was quite straightforward. Let us see if you can, during the break, do number 2 and number 3. Right, stay tuned, enjoy the show, and I'll see you immediately after the break. We back. I hope you guys enjoyed the break. I know you guys are sweating with the next question. Thank you to Hilaal. Hilaal was the parent that sent in the message. Thank you for watching the show. Big shout out to you. Thank you so much for sending such positive comments. And I hope you guys are enjoying today's show thoroughly. So thanks again, Hilaal. If your child is doing grade 12, I know the next 2 questions, they are stressing. They're telling you straight, the next 2 questions is the point in the exam where we tell ourselves, let's move on to the next question. At least we got 3 out of 14. Now, guys, 3 out of 14, 3 divided by 14 times 100 would only give you 21% for this question. So if you got the first question right, so we got cos 2 alpha is equal to PQ, right? We got cos 2 alpha is equal to PQ. You only got 3 marks out of 14. You only got 21%. Now, many of you, the parents, you look at your child and you say, oh my word, but you knew your work. And you said, yeah, but I answered the question. But you only got 21% for the question. Now, imagine you do this for your entire paper. I mean, look what your average is going to look like. So you better make sure you know these next 2 questions. So now we've got some thinking to do. Now we've got some thinking to do. Question number 2. We want tan alpha. Tan alpha in terms of P and Q. Now this one here, now there is no tan here. There is no tan here. We know that tan alpha is equal to sine alpha over cos alpha, right? We know that. But there's no sine alpha over cos alpha. There's no way you can get it here. So let's leave that. What alternate method can we use? Let's look at it. Now look at the question. Remember, these questions all followed each other. That's 1.1, that's 1.2. This is 1.3. So all these questions are all related to the same condition there on the top. It's all part of the same question. So we want tan alpha. Let's start off with what answer we got in question number 1.1. We're going to start off with cos 2 alpha is equal to PQ. We just found that out in the previous question. Now, how do I need to get a tan. So I want to be able to draw a triangle, a 90-degree triangle from here. And how am I going to do that? Cos 2 alpha is 1 minus 2 sine squared alpha. That's your double angle for cos. Is still equal to PQ. Right? It's equal to PQ. So let's go. Let's go. Now let's make sine alpha. Let's just find sine alpha. Let's find sine alpha. So take the 1 on the other side. So minus 2 sine squared alpha is equal to PQ plus 1 will come on the other side as minus 1. Now I'm going to divide by negative 2. I'm going to divide by negative 2. What am I going to get? I'm going to get sine squared alpha is equal to, because we're dividing by a negative, that sign can change. Negative divided by negative is a positive, and I'm going to swap these two around. So that's going to be 1 minus PQ over 2. Right? Now we want sine alpha. The opposite of square is square root. So now I'm going to say sine alpha. Therefore, sine alpha is equal to the square root of 1 minus PQ all over 2. Now, how does that help me to get tan alpha? Now we know that sine alpha is equal to the square root of 1 minus PQ all over 2. So let's draw our triangle. Now we know that this is over 1. We know that that is over 1. So if that is alpha, opposite over hypotenuse, so that's the square root of 1 minus PQ over 2 divided by 1. And we now need to solve for x. We need this side because tan alpha would be that over x. Do you see where I'm going with this? All right, so let's go. We need to find this last side. How are we going to do it? We're going to use Pythagoras. So let's do it here, right? After that, remember that's opposite over hypotenuse. Sine, according to SOHCAHTOA, is your opposite over hypotenuse. Opposite over hypotenuse. We need to solve for x. So 1 squared is equal to x squared plus the square root of 1 minus PQ over 2 all squared. Right, so 1 squared is 1 is equal to x squared plus, now all I'm going to do now is the square and the square root is going to cancel out. So I can just, that and that will cancel out. I'm left with 1 minus PQ over 2. So we want x. We want to isolate x. So 1 minus PQ over 2 is equal to x squared, right? We need to get to x. So let's sort this side out here. That's 1 over 1. Our common denominator here is 2. 1 into 2, 2 times 1 is 2, minus 1 minus PQ. 2 goes into 2 once. 1 times that will still remain 1 minus PQ is equal to x squared. I want x on its own. Therefore, x is equal to the square root of 2 minus 1 minus PQ all over 2. So this x is equal to the square root of 2 minus 1 minus p. You know what you can do here, guys? You can remove the inside brackets. Just follow my train of thought. This is the square root of 2 minus 1 plus p all over 2, which is equal to the square root of p plus 1. 2 minus 1 is 1. So it's p plus 1 over 2. So we can simplify that to this. So that's the square root of p plus 1 over 2. So in fact, what I am going to do here, x is equal to, that was that side. And we're going to say the square root of p plus 1 over 2. We're not yet done. All we did is we used Pythagoras. All we did is we used Pythag to complete our diagram. I hope you're following. I hope you're following. I know you're looking at this question and saying, damn, I think this question should be worth 10 marks in the exam. Well, it should have been. Okay, so let's go again. Where did we begin? Tan alpha. We started off with cos 2 alpha is equal to PQ, which we found in question number 1.1. Now, cos 2 alpha is 1 minus 2 sine squared alpha is equal to PQ. We're now making sine alpha the subject of the formula. Plus 1 goes on to the other side as minus 1. Divide by negative 2, divide by negative 2. Sine squared alpha is equal to negative divide by negative is a positive. So minus 1 becomes plus 1. Plus PQ becomes minus PQ all over 2. So sine alpha is the square root of this whole thing. So sine alpha is the square root. So that's your opposite. That's your opposite side over your hypotenuse. We draw our triangle. We moved over from there to here. All right. I know this to the ordinary eye looks Japanese, looks gibberish. Okay, grade 12s, you know exactly what I'm talking about. We move from there to here. So that was your reference angle alpha. Sine is your opposite over your hypotenuse. There we go. Opposite over hypotenuse. There we go. We use Pythagoras. This is Pythag. 1 squared, square on the hypotenuse, is equal to the sum of the other two squares on the remaining sides. So 1 squared is 1 is equal to x squared plus square and square root cancels. We left with that. I took that onto the other side. We simplified it. We got that. We simplified what's underneath the bracket. I get that. That is the square root of p plus 1 all over 2. Now we want tan alpha. Remember the question said, the question didn't ask you to draw the diagram. The question didn't ask you to do all of this. You had to know, you had to do all this calculation in order just to get tan alpha. Now we know tan alpha is equal to opposite over adjacent, according to SOHCAHTOA. You guys all remember SOHCAHTOA? Right, according to tan is your opposite over your adjacent. Opposite over adjacent, which is your adjacent side. X that we just found. That's your adjacent side. So let's go. I hope you took this down. Guys, if you missed the show or if you missed any part of the show, it's going to be uploaded onto YouTube under Hilaal TV tomorrow. So I promise you, please just go through it over and over and over until you understand it and until you master it. So I'm going to need to erase this for now, because we now need to answer the question. We're not yet on to 1.3. 1.3 is another killer. 1.3 is another killer. So let's go. So we're done with this. Right, so let's go. So tan alpha, let's just see. I think a question came in, but I hope it's relating to this question. Right, let's see what it says. Why didn't we use 2? You could have used 2. Okay, so the question that came in, could we have used that? Could we have used 2 cos squared alpha minus 1? Yes, you could. You would get exactly the same answer, right? So you're on the right track. I just use sine. I use sine. You could have made this 2 cos squared alpha minus 1, made cos alpha the subject of the formula, drawn your triangle. Cos would have been adjacent over hypotenuse. I think you know what I'm saying now, because you're following. I can see clearly you've asked the question, could we have used 2 cos squared alpha? My answer to that is absolutely. You could have. You would have got the same thing here. We're now going to get into tan alpha. So now tan alpha. We're still answering the first question. Can you believe it? Tan alpha is equal to opposite over adjacent. So tan alpha. What is your opposite? Your opposite is the square root of 1 minus PQ over 2 divided by your adjacent. Right? Divided by the square root of P plus 1 over 2. That is equal to, let's do this. This is the square root of the whole thing of 1 minus PQ over 2. We tip it times 2 over, we flip the side because we tip and times it, times 2 over P plus 1. And that is going to give us the square root of 2 and 2 will cancel. Numerator times numerator, 1 minus PQ over 1 times P plus 1 is P plus 1. Bada bing, bada boom. And there we go. That's your final answer. This is your opposite. This here is your opposite. That's your opposite. Divided by your adjacent. Opposite, I just moved it over because I didn't want to have a fraction over a fraction. I moved it over onto the side. Single third, and we're dividing the two so we can tip and times, and then we cancel what's common, and then numerator times numerator, denominator times denominator. There's your final answer. Okay, let's see. Let's check the comments. Yes, it's coming right. You guys are enjoying it. I know you're loving it. You're checking it out. And that is, of course, your final answer. If you use the 2 cos squared alpha minus 1, I promise you, you must have got exactly the same result. All right. So I hope you got it down. A lot of writing, a lot of work. This one would have probably taken you a page of calculation. There's no shortcut to this one. There is no shortcut that I could see doing this problem. If you got a shortcut, send it, do it on a page, and send it to the WhatsApp number that appears on your screen. Okay, send it to the WhatsApp number 065 863 1440 if you have a shortcut. But I don't see a shortcut to this problem here. Let's do the next one. Right, let's do question number 3. Now, I know you guys are sweating. Grade 12s, you are sweating with this question, right? But these are our higher order questions. These are our higher order questions. Let's see what we can do, or what can we do with question number 1.3. So we're done with this one. We're done with that one. We got 3 and 5. We got 8 marks out of 14. We still need to get our last 6 marks. Whew, let's see. What are we going to do with that? So we're going to say P over 2Q minus Q over 2P to a single trig ratio. To a single trig ratio. So let's see what are we going to do here. We're subtracting. The common thing to do in algebra is to find our LCD, right? So I'm going to find my lowest common denominator. So a 2 and a 2 will only go into a 2PQ. Right, let's see. The 2Q and the 2Q will cancel out. We're left with P. P times P is P squared minus P and P will cancel. You're left with 2Q. 2Q times Q is 2. The 2 and the 2 will cancel out. The P and the P will cancel out. Q times Q is Q squared. Right, so we're left with that for now. Let's see what you can do. I'm just going to go back to the numbers. Why are you using 10 on number? Let's see, where did the Q go for the X on the theorem of Pythagoras? Why are you using 10 on 1.3? No, 1.2. 1.2. To answer your question, we used 10 alpha. The question asked us to find 10 alpha in question number 1.2. That answers your question. Question number 1.3 is a completely separate question. You need to bring this to a single trig ratio of alpha. That's question number 3. So we're not using 10 alpha here at all. 10 alpha was for question number 1.2. So now, P squared minus Q squared over 2PQ. So P squared minus Q squared, we know is a difference of 2 squares. P minus Q, P plus Q, all over 2PQ. Now, P minus Q would be, so now we're going to have to break this up. P minus Q, what is P? Cos alpha plus sine alpha, that's P, minus Q. Right, what is Q? Minus, and I'm going to put it in brackets, cos alpha minus sine alpha. Right, so that's P minus Q. We now need to go P plus Q. So I'm just going to move over here to the side. I'm going to move over here to the side. Let's check this. Let's check this. So maybe we can use square brackets here. So let's use square brackets. Let's use square brackets. And then we're going to break this up. So difference of 2 squares, right? P plus Q. So what is P? Cos alpha plus sine alpha plus Q. Plus Q. So plus cos alpha minus sine alpha. Whoopsie. So plus sine alpha all over. We got 2. P is cos alpha plus sine alpha. That's P. That's P. Plus sine alpha into Q. Cos alpha minus sine alpha. Cos alpha minus sine alpha. Let's double check if we are right. Common denominator, 2pq. Right, 2 and 2 will cancel. Q and Q will cancel. P. P times P is P squared. That's right. Minus. 2 and 2 cancels. P and P cancels. You left with Q. Q times Q is Q squared. That's right. All over 2pq. Now, P squared minus Q squared is your difference of two squares. So there we go. P minus Q, P plus Q over 2pq. That's correct. Now, P minus Q. That's P minus Q into P plus Q all over 2pq. There we go. So we don't think we're right. We know we're right. Let's go. What are we left with? Cos alpha plus sine alpha minus cos alpha plus sine alpha. I'm multiplying this negative inside. All over cos alpha plus cos alpha is 2 cos alpha, right? Plus sine alpha minus sine alpha is out. All over 2 into. Cos alpha plus sine alpha minus sine alpha is a difference of two squares again. Cos squared alpha minus sine squared alpha. Right? Difference of two squares at the bottom again. Let's see. We're not yet done. So cos alpha minus cos alpha. Looks like we're spinning here, but don't worry. We're coming right. We're coming right. 1 sine alpha plus 1 sine alpha is 2 sine alpha into 2 cos alpha all over. Let's leave this as 2. And what do I have here? What do I have here? I've got cos squared minus sine squared, and this here is cos 2 alpha. That is your formula. This is your formula for cos 2 alpha. So now over 2 cos 2 alpha. We're not yet done. I'm going to move over to the side. Whew, it's a build-up. It's a build-up. It's a build-up. I'm sweating. Right, 2 times 2 is 4 sine alpha cos alpha. 2 times 2 is 4 sine alpha cos alpha. I know South Africa, matriculants, grade 12, some of you are waiting. Please, Mr. K, mess this one up. Mess it up. Mess it up. It ain't happening. It ain't happening on the show. We never say die. All over. They're waiting for me to fall. They're waiting for me to get it wrong. Over 2 cos 2 alpha. Ha! Let's go. I don't think I'm right. I know I'm right. This is equal to, I'm going to break this up into 2, right? That's 2 into. I'm going to break the 4 up into 2 times 2 will give me 4. And then I'm going to be left with sine alpha, cos alpha, all over 2 cos alpha. There we go, 2 into. Now, 2 sine alpha cos alpha. That is my double angle for sine. So that is sine 2 alpha. I know I'm getting an applause. Thank you. I know you guys are screaming there. Yay! Some of you, haters, trolls. I know you're saying, damn, man. Why did he have to get it right? All over 2 cos 2 alpha. Yeah, like a boss. Like a boss. So this is going to equal to 2 and 2 will cancel. We left with sine 2 alpha over cos 2 alpha as a single trig ratio. Sine 2 alpha over cos 2 alpha is tan 2 alpha. I don't think I'm right. Ladies and gentlemen, boys and girls, I know I'm right. And there we go. Somebody found a quicker way in the previous one. That would be nice. Let's have a look at the quicker way. You guys are working it out there. So PQ, okay. Let's see what you did. Okay, you did the same thing as me there. And then you did 2 sine alpha cos times 2 cos alpha. Yeah, but you had to do P minus. It's almost the same. It's almost the same. You had to have done this on the side. How did you just get 2 sine alpha as P minus Q? That's what I want to know. P minus Q. So you had to have taken that minus that to get 2 sine alpha. All I did, you did it on the side. Okay? The learner who say you got it in a shorter way. You did what I did here. You did it on the side and then you got 2 sine alpha because you took P minus Q. Cos alpha minus cos alpha plus sine alpha, then minus sine alpha would have given you plus sine alpha plus sine alpha would have given you your 2 sine alpha. But you had to have done this on the side. And then the P minus Q, you had to have done that on the side to get 2 cos alpha. So I don't think it's a shorter cut. What you did is you did it on the side. I included that calculation in my problem. Okay, but in any way, you did it, you saw it, you liked it, you enjoyed it, and you got yourself a full 14 marks for this question. Boys and girls, this is bringing us to the end of the show, right? We're going to be doing some Euclidean in our next show this Thursday, right? So stay tuned. Hope you guys enjoyed today's bumper explosive show. I'm sweating at the back of my neck. The sweat was dripping here while we were doing this question. Remember, I'm doing it like you, tackling it for the first time here on the screen. And I've also here in studio, I got to make sure I get it right. I can't stand here and you know what they say in Afrikaans, krap kop. Okay, I don't even have a hair to krap. Right? So, guys, thank you so much for watching today's show. I know you guys loved it. Send your comments to Hilaal TV. Tonight's episode will be on YouTube tomorrow under Hilaal TV. Just search it under Hilaal TV and you'll get today's show. Guys, I'm your host and your presenter on your favorite math show brought to you by K-Way Institute. I'm Mr. K from the K-Way Institute and Qurtuba Online from our studios here in Johannesburg, South Africa, Rivonia. This was our live show Thursday night, same time, 9 p.m. Catch you there. Euclidean Geometry. Assalamu alaikum. Good evening.